All right, so they're asking you to find x. So I look at the segment that involves x, okay? And if we look at that, there's a midpoint right here for this overall triangle. This is a midpoint right there. So that means that this red distance here is a midsegment, right? And we said that midsegments should be parallel and half the length of the other side of the triangle, or the third side of the triangle. So the third side of the triangle is 8x minus 30, and the midsegment is x. Okay? Now, that's not an equation right now. They are unequal right now. So I'm going to put a question mark right there. So I just leave them that way, it's saying it's the same length, right? I got to figure out where either my 1/2 or my 2 goes in this equation. Okay? So when I read this, I read the midsegment is half the third side, right? So when I look at it that way, I could go the midsegment, which was x. That symbol means is, and then half the third side. Well, this is the third side. Half of it, algebraically, half means multiply, right? So that would be the equation that you want to set up, or one of the possible equations you would set up to solve for x. Another way of saying it is that the third side, our 8x minus 30, is twice as big as the midsegment, so 2x. Okay, so either one of those equations is perfectly fine. Solving maybe this one down here, I subtract 8x from both sides, and I'll get negative 6x over here, negative 30 there, so x becomes 5. If I do the work up here in this equation, I should get the same answer. I would, in this situation, distribute the 1/2. Makes it 4x minus 15 is equal to x. Subtract 4x from both sides. Gives you negative 15 equals negative 3x, so x again has to be 5, right? At this stage here, if you wrote this equation where the 1/2, 8x minus 30 equals x, you've got options. You can distribute the 1/2 like we did, like I did. Or you can multiply the left-hand side by 2 and the right-hand side by 2 to get the 1/2 to disappear. And if you do that, it develops this equation right here. Okay? So that's kind of how you would want to approach that question. I think a lot of people maybe got stuck on this by looking, which it makes sense that you would struggle with this if you look here. But they see the 6x plus 10 bear with me. They see that 6x plus 10, right? So that's an expression that has x with it. And then they compare it to this midsegment that has y in it, and they're not sure what to do, right? Well, you create an equation there that says, 2 y's can equal 6x plus 10, but you're only going to be able to solve that if you know what? You know y, right? Okay, we don't know y. So even though that's a true equation, it doesn't get you anywhere. All right, so you have to look somewhere else in the problem. So this information there and there is just there to defeat cluttering. Okay, things that we don't necessarily need. Is that doable? Okay, so that was question 17. Do you guys want to talk about 18? This one here? Okay. See some heads nodding up and down, so we'll do it. Let me see here. Just want to get some points that were different than the one I did last class. Okay. So we've got E is located at 2, 3. F is at 6, 9. G is at 4, negative 3. Just trying to give myself a little room here. If we read this, I know it's zoomed out, so you might not be able to see from your seats, but the directions say here, find the coordinates of H, which are the midpoint of EG. Okay? So EG is this segment right here. Okay, see if I can color this for you. EG being that segment right there, we want to find its midpoint. Okay? Well, if you remember midpoints, the formula is to add the x values divided by 2, add the y values divided by 2. Okay? I'm getting a lot of people to find midpoints by trying to subtract. Okay? You're always going to add them. I think we get the slope formula confused with the midpoint formula. Okay? So make sure we know which one is which. So e to g, add the x values, get 6, divide by 2, you get 3. And then do the same thing with the y values, and you should get 0, divide by 2, you get 0. Now just make sure that when you're done, before you type in your answer, plot 3, 0, where my cursor is, and does it look like it's the midpoint? So that's kind of verification that you've done things right. If I would have done subtraction, for instance, 2 minus 4, got negative 2, divide by 2, get negative 1. And then go 3 minus negative 3 gives me 6. Okay, 6 divided by 2 would be 3, right? Plot negative 1, 3. Is that the midpoint between E and G? No. Okay, so you have the ability to quickly reference whether you've done things correctly or not before you type answers in. So that gives me 3, 0. Put a slash mark there, so it's going to tell me I'm wrong. There we go. We want to do the same thing for J then. So J is the midpoint of F to G. Okay, so F to G, I'm going to add those again. So that's 10 divided by 2 would be 5. And then 9 plus negative 3 is 6 divided by 2 is 3. So I'm looking at 5, 3. Again, plot that point, 5, 3, about right there. Looks like a midpoint, so I'm pretty confident in that answer, and I'll type that in. So 5, 3. Next thing they want to know is, are these two segments, the one that you just defined the endpoints for, in EF, are they in fact parallel? Okay, so here's where we need to use slope. Okay, this is H, and that point there was G. So I'll find the slope of H to G. Slope of H to G is going to be, subtract your y values, so 0 minus 3. It's be negative 3 up top. And then subtract my x values. So 3 minus 5 gives me negative 2. So that gives me 3 over 2. Okay. Now I'm going to do the same thing for EF. So slope of E to F. Subtract my y values. So I get negative 6 up top. 3 minus 9. And on the bottom, we'll go 2 minus 6. Gives me negative 4. That reduces to 6/4, but it also reduces then further to 3/2, right? So is that verification that those two lines are parallel? Okay, when the slopes are the same, lines are parallel. So type in 3/2. Just type an integer or a simplified fraction. So if I typed in 1.5, it counts it wrong, correct? So 1.5 is not a fraction or an integer. So I need to go 3/2. Next part says find distance to prove that these two things are in fact showing the relationship that midsegments should show, with distance being the length of a midsegment being half that of the third side. So we want to find the distance of H to G. Okay, so remember that, subtract your x's and then square that, so it gives you 4. And then subtract your y's and square that, gives you 9, right? So we get radical 13 for H to G. I'm then going to do the same thing for E to F. Take my x's and subtract them. I get 4, square that, you get 16. Same thing for your y's, then you get 6, square that, you get 36. 16 plus 36 is 52. Okay. Now, if I look at radical 13 and radical 52, they don't show this relationship. If I were to type those in, it tells me I'm wrong, and I'm actually going to do that to just kind of prove it to you. If I say EF is square root of 52, and HG is radical 13, even though those answers are right, it tells me I'm wrong. Okay? So, what we need to do, and it does say using radicals as needed, type exact answers. That's kind of, it's not very explicit, but it means simplify things. If I go ahead and look at 52, radical 52, let me just create some room up here. Radical 52 is equal to radical 4 times radical 13. Okay? 4 times 13 is 52. Take the square root of 4, you get what? 2, right? Does 2 radical 13 being EF and radical 13, 1 radical 13 being E or HG, does that prove to us now that one is half of the other one? Does that make sense to everybody? Because they're both the radical 13s, and this one has a constant of 2, or a multiple of 2 out front. This has a multiple of 1. So what you need to do is write that EF is 2 radical 13, even though they're the exact same values. And now it's going to be correct, because now that is showing this relationship that it is equal to 1/2, that radical 13 is equal to 1/2 EF. Does that kind of make sense? When in doubt, always simplify radicals. Okay. Do you guys